Good morning, dear students. So on the previous practical lesson, we studied basic methods of integration. So used table of integrals, uh, differential enter technique, integration by parts, and so on. So today we will integrate rational fraction and some irrational functions. So let's start. So the first task is to find integrals using the integral decomposition and the perfect square techniques. So just a moment. Let me write down it and I will explain the idea. So this is 1a. What do we have here? We have irrational, so we have a rational fraction, and we need somehow to modify it to make it the table integral. So we don't have anything now to enter under differential, so we need to modify it. And how can we do it with integrals of such denominator? We just need to extract the perfect square. So the perfect square will be the following. So first of all, let's decompose it. So 3x is a double product. So plus 2 by 3 over 2x plus 9 over 4 and minus 9 over 4 and minus 10. So actually nothing changed, so the equality is not broken. So now let's so when we have the perfect square, and let's collapse it. So what do we have here? X plus 3 over 2 and in power of 2. And what do we have here? So minus 9 over minus 9 over 4 minus 10. So minus 40 over 4. So it minus 49 over 4. So that's what we received. And now we use differential enter technique. So actually this is the same. So nothing broken here, but we entered this expression. So this expression is under differential. So now we have the table integral, the following integral. Let me just remind you. So the next logarithm. I forgot a little bit about numerator and denominator, where is plus and where minus. So let me look into it here. So sometimes I forget about them. Yeah, and by the way, so minus a minus x. So this. So logarithm a of a plus x, and here in the denominator a minus x plus constant. So also we need to modify this integral a little bit just with changing the sign. And we will receive the table integral. So actually 49 over 4, it is 7 over 2 in power of 2. So this is A, 7 over 2. So now calculating the integral. 1 divided by 2A is so uh, uh, 2 by 14. So because 2A is 14 over 2, but we divide it. And the logarithm is the following. So x plus 3 over 2 plus 7 over 2. Oh, no, we uh, so vice versa actually. Yeah, for numerator it doesn't matter, and here minus, so minus x minus 3 over 2 plus c. And now let's just let's simplify a little bit. So 1 over 7 logarithm over, so here 10 over 2, so x plus 5, and here so 7, so 2 minus x plus c. So any questions about this task? Is everything clear?
I've got a question. Why
Yeah.
did we put x plus 3 over 2 on the under differential instead of x?
Okay. So actually, if we differentiate this expression, so x plus 32, we will receive the same as dx, because constant will be differentiated to 0. X will be differentiated to 1, so it's like 1 by dx.
Oh, oh
I
yeah,
answered
I
your
see it.
question.
Yes, you did. Thank you.
More questions? Okay, if no questions, let's move to the next task. So now we have, so part C is more interesting. So B is analogical to A, but we have irrational as well. So irrational part, irrational fraction, but you already know the idea, just to extract a perfect square and then transform it to the table integral. And now let's go to C. Let me restart. So the following integral. So how to solve? Actually, we need, so in this case, we need to uh, split it, split it by two integrals, but first of all, let we extract the perfect square. So actually, the perfect square in this case is the following. So we receive this. So x x in x plus 1 in power of 2 and plus 1. Okay, and now let's expand so let's expand the denominator numerator. So if we do it, what we will receive? So 3x stop. So 3x dx here we will receive, and here just dx. So this is the table integral, but now we leave it like this. So what do we have here? Actually, let's rewrite it with the old form of the expression under the root. And what do we see? What do we see? So actually, this part, so the numerator is a little bit similar to the differential of the expression under the square root, but not really. So the differential of this expression is the following. So it equals 2x plus 2 dx. So we need to transform the numerator to this part, so to look like this. So first of all, what we so let's move 3 and so out of the integral sign, and let's divide it by 2. So step by step, 2x dx, and also let's add 2 and subtract 2. Subtract 2, and also let me not lose this fraction, this integral. So if we look at this integral and this integral, so if we expand brackets, so nothing will change, so it will not break the equality. And now let's expand brackets for this integral and what we will receive. So just to transform it to be differential. So this and minus 3. So minus 3, and here we have just dx. Yeah, so minus 3 because we because we divide, so we multiply 2 by 3 over 2. And this integral as well. So writing everything in details, yeah, I know that some steps could be skipped, but let we better write everything. So now we have, so here we have differential of this expression. So let's just copy and paste this. And this is the table integral, actually. And what about this? So minus 4, yeah, these expressions are equal. So minus 4. These integrals, and this is basically the the differential of this expression, so x plus 1, so nothing changes, as I explained before. So now we can integrate. So for this integral, so 3 over 2, and so we will receive 2 square roots of this. So So if we integrate this, so without coefficient, so 2 square roots of this, but as the result, so 3 square roots of this expression. And plus, so basically, let's remember what this integral means. So this is the following expression. So the logarithm, yeah, in and module sign. So logarithm of x plus 1 and plus this square root plus c. So it's done. Any questions about this exercise? So it was quite big. Or everything is clear. If so, let's move next. So we will try another approach. So we will find integrals by isolating the integer part of the integrand. So what does it mean? So we have some fractions for which power of the numerator is greater than the power of denominator. And this is like irregular fraction. Actually, if degrees of numerator and denominator are equal, this fraction is also irregular. So incorrect fraction. So we need to isolate the integer part of the integrand, and then we will be able to integrate it. So let's solve part B because it needs less calculation. But you will just understand the idea, yeah. And here the process is skipped. So x in power of 2 plus x plus 1, x plus 1, yeah, and dx. So I wrote it down, and now let's divide the numerator by a denominator. So we will need to use paint. So we firstly look at the first, at the greatest degree of the numerator. So here x, and we multiply it. So multiply by x square plus x. So here is 0 and just so plus 1. So what we receive here, yeah, let me, yeah. So everything is correct. So what we have here will remain in the numerator, and this is the whole part. So if I, yeah, so let me rewrite it first of all. So x plus 1 divided by x plus 1. And what do we have actually? So if I multiply it by x. So if I find the common denominator, we will receive this expression. So it's obvious. So x square plus x and plus 1. So for this example, it is easy. And now we can expand brackets. So let's expand. So first integral x dx, that is the table integral. And the second, let me move x plus 1 under the differential. And now we integrate it. So in the first case, 1/2 x in power of 2 plus logarithm over module of x plus 1 plus c. So any questions about this exercise?
I don't think so.
Okay, so let's move
Probably
next,
not.
if no questions. Okay, so so A and C exercises are analogical. And now let's do more practice with the other cases. So actually these cases and yeah, and what we and we will have also these irrational functions. But first of all, let's move to rational. Okay. So now we will use method of undetermined coefficients. So how it works, I will explain you. Uh, but first of all, let me write down the integral. Okay, so we have such fraction. How to integrate? Of course, we can expand brackets and try to use differential entry technique. So we can expand this expression, but don't you think that it will take a lot of our time? So that it is too complicated. I think so. So we will use method of undetermined coefficients, and it looks like this. So so we will write it. So actually, what do we see? So this is the common denominator for three fractions. So x minus 1 multiplied by x plus 3 multiplied by x minus 4. And this is the common denominator for such fractions. Plus, let me avoid, so I don't want to use C here, I will use D, because we use C for the constant. And in our examples, actually, I did like that, but of course, you are free to use letter C, but it is better to, for example, to mark it like this, to like with the way, with such wave, or maybe like hat and so on. But okay, let's leave D. So we actually have such fractions, simple fractions. A, B, and D are usual numbers, real numbers. Now we are finding the common denominator. So For a, to multiply these fractions, we need, multiply a by x plus 3 and x minus 4 plus b multiplied by x minus 1 and x minus 4. Okay, let me move to the next line. Plus d multiplied by these expressions. And now let we expand brackets near each of these coefficients. So for a, so x, okay, let's, so x square plus, minus, 3 minus 4, so minus x and minus 12. Plus b, so multiplied by x square, so minus 1, minus 4, minus 5x, and plus 4. And for d, x square, so minus 1 plus 3, so plus 2x and minus 3. So we have like this. And now let's expand brackets completely. So ax square minus ax minus 12a plus bx square minus 5bx plus 4b. Then plus dx square plus 2dx plus 3d. What are we doing now? Now we need to regroup these addends according to powers of x. So what do we have? So for x square, so a plus so a b and a plus b plus d. So here. And for x, so minus a, minus 5b, and 2d. So minus a, minus 5b, plus 2d. And so for x in power of 0, so minus 12a, plus 4b, and minus 3d. So we regrouped this. So we regrouped this addends, and what do we? So now let we see. Let's look at these two expressions, and your ideas and suggestions what to do the next. So if we look at this numerator and this numerator, so what to do? Your ideas how to find coefficients a, b, and d. So Vadim, yeah?
Maybe construct a system of equations.
Yeah, correct. So now we need to construct and of course to solve the system of linear algebraic equations that you already know. So a plus b plus d actually equals 2. So let's write down the first equation. So it equals 2. Minus a minus 5b plus 2d equals 41. And this expression minus 12a plus 4b minus 3d equals minus 91. So we have such a system of linear algebraic equation. Now let we not waste our time to solve the system of equation. You already know how to so know different ways to solve, such as Cramer formulas, inverse matrix, Gaussian elimination, maybe Jordan Gauss elimination, and so on. Now let's just write down the equation, solution here. So 4 minus 7, 5. But of course, when doing your individual task, solve this equation system. Okay, so what we receive finally? So this the next integral. So 4 over x minus 1 minus 7 over x plus 3 plus 5 over x minus 4 dx. So actually, yeah, we know that these denominators can be moved under the differentials. We can expand and write like a sum of integrals, but we actually understand that, so we see table integrals here. So the first is logarithm of x modulo x minus 1. The second is so minus 7 over logarithm. So for some reason move to another line. So 7 logarithm over x plus modulo of x plus 3 and plus 5 logarithm over modulo x minus 4 plus c. So it's done. Any questions about this exercise? About such method? Okay, if no questions, let's move next to the next exercise. So similar to it. Also, we'll use the method of undetermined coefficients, but in a little bit other way. So actually, so it is another case of undetermined coefficients method. Also, it will be useful for differential equations. So I guess we will use it also in the final season. So we have such integral. So this is the correct fraction. And now let's use the method of undetermined coefficients. So here we have complex power, so power of 2 of this expression. So actually, how do we write it? So a plus, so we, of course, we take into consideration all powers. So a plus b divided by this expression. So x minus 1 in power of 2. If it was power of 3, we had to write also, for example, c divided by x minus 1 cube. And let we not forget about x, so this one. So again, writing down the common denominator, So a by x minus 1x plus b by x plus d multiplied by x minus 1 in power of 2. So expand in brackets. So ax square minus ax. Oh, not like this. So ax square minus ax. So expanded everything here. Plus bx plus dx in power of 2 minus 2 dx plus d. So just skipped some steps, so just made it made them all together. And now let's regroup the addends. So for x square, what do we have? A plus d. For x, so minus a plus b minus 2d, and for the 0 power, just d. So again, we received a system of linear algebraic equations. So a plus d equals 1 minus a plus b minus 2d equals 4, and d equals 4. We even can solve this system here because it's easier than in previous exercise. So d equals 4. So if a plus d equals 1, it means that a equals minus 3. And for b, so 3 minus 8. Okay, so b equals, so okay, so minus 3 plus b minus 8 equals 4. So the minus 5, so b equals 9. So quite easy for this exercise. And now let's write down the integral. So minus 3 by x minus 1 plus 9 by x minus 1 in power of 2 plus 4 over x dx. And now calculating these integrals. So the first one, 3 logarithms of module x minus 1 minus 9 divided by x minus 1. So because we will receive so we divide by minus 1 because we receive such power, plus 4 logarithms of module x plus c. Any questions about this task?
Not really, no.
Okay, so now no questions, and yeah, I see that it is time for break, but first of all, let we finish this exercise because then we will solve we will calculate irrational integrals from irrational functions. So just not to mash up everything in our heads. So we will solve one more case of such of undetermined coefficients usage. So if I rewrite this fraction, so yeah, first of all, let's factorize the denominator. So if we factorize what we receive, so x square plus 1 multiplied by x minus 1 multiplied by x plus 1. So we have such fraction. And here we see that so we cannot expand it anymore. So x squared plus 1 equals 0 does not have real roots. So we write it like this: ax plus b. So it looks like this for such expressions: plus d over x minus 1 and plus e over x plus 1. And we do the same that we did before. So the common denominator, so ax plus b multiplied by x squared minus 1. So I just multiplied, so collapsed it. So plus d multiplied by x squared plus 1 by x plus 1 plus e multiplied by x square plus 1 and multiplied by x minus 1. Now let's expand brackets again. And what we will receive? So ax cube minus ax plus bx square minus b. Actually, I don't need such brackets. And here plus dx cube plus dx square plus dx plus d. And for e, so the same situation. So e x cube minus ex square plus ex minus e. And now we regroup our coefficients as we did before. So for x cube, so a plus d plus e. For x square, what do we have? So b plus d plus e. For x for x in power of 1 minus a plus d plus e. And for power of for x in power of 0 minus b plus d minus e. So again, we have the system of linear algebraic equations. Yeah, Bogdan, you have a question?
Yeah, I think you made a mistake. For x to power of 2, it should be minus e and plus
Yeah,
from
thank you for your
plus.
attention. Yeah,
Yeah.
let we not use
You're welcome.
signs. Signs don't like this. Okay, and now we have the algebraic equation, so system of linear algebraic equations. We won't solve it for now because it requires a lot of time. Okay, so for x in power of 2, 0. So minus a plus d plus e equals 1. And this equals 1. So actually, yeah, so I won't say that this system of equations is such complicated, but yeah, we just want to save our time. So let's just look at what is written here. So a equals 1 over 4. B equals 3 over 4. D equals 0. And E equals 1 second. So now let's write the integral. So we have such sum of integrals. So D is 0, nice. So plus 1 second of integral. So dx by x minus 1. So what we actually have here? Yeah, so let's rewrite it to sum of integrals. So it will be easier. So 3 over 4. So dx here plus 1 over 4 of x and dx. And we have 3 table integrals. So first of them, so 1 over 8 logarithm of x square plus 1. The next integral, it is arctangents. Oh, no, stop. Just a moment. Yeah, so it is arctangents actually. So, yeah, plus 3 over 4 arctangents x and plus 1 second logarithm of module of x minus 1 plus c. So any questions for now about this exercise? Or no questions? Okay, I guess that no questions, so let's have a break for 5 minutes and then we will continue, we will calculate integrals of irrational functions. Okay, let's continue. So now integrating irrational functions. Yeah, you had anybody, so someone had a question? Or raised the hand by mistake? Anyway, you always can feel free to ask me questions, you know it. So let's write such integral. So 1 plus, damn it. 1 plus root of power of 3, so in power 4 dx. So your ideas how to solve it, your suggestions. Okay, so we need to make a substitution. So how to, so we need to rationalize this integral. So if we rewrite it, so let's rewrite it in like powers. So x in power of 1 second, and here x in power of 1/3. So we have such powers, and we need to rationalize this integral. We need to make a substitution. So we'll make the following substitution: t equals x in power of 1/6. Why 1/6? Because it is so 6 is the common denominator of such fractions. So t equals x over, so x in power of 1/6. Then x equals, so x equals t in power of 6. Oh, yeah, x equals t in power of 6. So dx equals 6t in power of 5 and multiplied by dt. Also, what about these fractions? So x in power of 2 equals t cube, and x in power of 1 second equals t square. So now rationalized the integral. Okay, let me also mark it like this. So I, and now I equals, so we have the following integral. So here is t square, t cube, multiplied by 1 plus t square in power over 4 plus, and multiplied by t, yeah, multiplied by 6 6t in power of 5 dt. And let's rewrite it. So we have integral of a polynomial function. T in power of 8 and 1 plus t square in power of 4 dt. So we have such expression. Unfortunately, so we have no possibility to use, for example, so we don't have the chance here to integrate it by parts, yeah, so it even will make it more complicated. Or so we'll have to integrate by parts 4 or 8 times. Differential entry technique also doesn't work, so let's just expand brackets. So if we expand, I will receive the following integral. So t in power of 8 and multiplied by t in power of 8 plus 4 t in power of 6 plus 6t in power of 4 plus 4t square plus 1 and dt. And now let's expand it completely. So 16, 14, 12, 10, and t in power of 8. And what finally do we have? So let's calculate. So 1 over 17 t in power of 17 plus 4 over 15 t in power of 15 plus 6 over 13 by t in power of 13 4 plus 4 over 11 t in power of 11 and plus 1 over 9 t in power of 9 plus c. But so we found the integral, but it was required to find the integral from a function that depends on x. So this is the not final answer. So what to do? We need to return to the previous variable, to the variable x. Yeah, and I see that it is not it is not so convenient because of such fractions. I know. So how to solve this problem? So what we can do else? So instead of returning to the old variable, we can just write like this, where t equals x in power over 1 over 6. I guess you like it more than returning to old variables. Of course. So when doing your individual tasks, don't forget, so either return to old variable or write like this, where t equals so some expression from that depends on x. Any questions about this task? Well, so why did we take x in power of 1 over 6? We substitute the latest, so the least power, so the least degree in this, least possible degree in this expression. Okay. So what next? What can we solve as well? Yeah, Bogdan, question?
Yeah, I have a question. How did you decompose like the this expression 1 plus t to power of 2 and everything, and this in power of 4. You decompose it to t to power of 16 plus 4 to power 4 times t to power of 14
So
and so on.
you mean this expression? Yeah.
Yes,
Well,
yes.
for now, I just looked into this. So looked into my materials, but you can do like this. So x plus 1 in power of 2 in power of 2. So you can first expand it, then expand again. But you know the triangle of Pascal. Okay. Let me let me remember it. So actually, this is for square polynomials. So here is the sum of this. So sum of neighbors at the top. So 1 plus 2. So do you remember maybe it from the school?
Yeah, I remember something
Yeah,
like
so
this.
like
Yeah.
using this approach. So for small powers, we can do like this. Of course, if it's power of 100, 1000, we need to use other approaches. So have I answered your question?
Yeah, you did. Thank you.
Okay, you're welcome. More questions? Okay, I guess that no questions. So let's look into this integral. Yeah. Okay, so let's yeah, again, let's start solving. Yeah, so let's solve it with the substitution. So yeah, I see that we have enough time to calculate both these integrals. So we have such integral. So x in root of the cube root of x square minus root of power of 4, the power of 4 of x dx. So again, what we have to do? So we need to make the substitution. So again, substitution for the least degree. What is the least degree here? So we need to find the common denominator. The common denominator for all these fractions will be, so the least common denominator is 12. So t equals x in power of 1 over 12. Then x equals t in power of 12. Dt or dx equals 12, 10 in power of 11 dt. And then so x in power of 1 second equals t in power of 6. X in power of 2 over 3 equals t in power of 8 and x in power of 1/4 equals t cube. So actually transformed everything that we could in the integral. So what do we have now? So x, so in the numerator, so t in power of 6, and here t in power of 12 t in power of 11 dt. So 12 t in power of 17 dt. And in the denominator, t in power of 8 minus t cube. What can we do? So just right now. So we can cancel t cube. So we can simplify the expression. What's going on? Okay, so let's move 12 out of integrals. So here we will have 1, here t in power of 5, and here 14. And what can we simplify? Actually, nothing. So we cannot use differential entry technique. So for example, yeah, so if we use but. By the way, so t in power of 4, for example, by going on. Uh, by t in power of 5, yeah, in power of 2, this it will be well, yeah, it will not help us, so we just need to divide, so to extract the whole part. So we won't calculate everything to extract the whole part. We'll just use this recordings. So this record that we have here. And what we have? What do we have? So t in power of 9 plus t in power of 4 plus this expression plus 3t power of 2 plus 2t plus 1 and divided it by 5 t in power of 4 plus t in power of 3 plus t square plus t t plus 1 and plus 1/5. Yeah, also expanded it so to different fractions. So t plus 1 and dt. So what do we see here? So we can expand it like so. Here we see that in the numerator, this is the differential of the denominator. So here is the derivative of this expression. So let's differentiate it. So let's integrate everything. So actually, I will leave everything in the brackets. So 1 over 10 t in power of 9 plus 1 over 5 t in power of 5 plus 1 over 5 logarithm of this expression plus 1 over 5 stop, logarithm t minus 1. Yeah, and plus c. Yeah, and finally we need to write down value of t. So where t equals x in power of 1 over 12. Any questions about this task? Yeah, some steps were skipped, but so just to save our time. Okay, if no questions, let's solve one more exercise, and then we will finish. So the following exercise, the following integral. So x dx, and again we have irrational expressions, x plus 1 plus so cube root from x plus 1. And what do we have? So again, let's write powers in, so let's write root, so let's write powers instead of roots. So we have this. And now, so we need to make a substitution. The substitution here will be the following. So we need to substitute this expression. So to remove absolutely irrationality, so we need to rationalize our integral. And the substitution will be the following: t equals x plus 1 in power of 1 over 6. Then, so x plus 1 equals t in power of 6. Then, so actually I can even, okay, so let's write in detail. So x equals t in power of 6 minus 1. So dx equals 6t in power of 5 dt. So 1 was destroyed while differentiation. So x in plus 1 in power of 1 second equals t cube. Volodymyr, okay. We'll let enter, but use better your corporate emails. Yeah, I know that sometimes such situations happens that we have no ability. Okay. So took everything into consideration and now write an integral with the new variables. So x, so t in power of 6 minus 1 by 6t in power of 5 dt, and what here? So t cube plus t square. So again, we can cancel t in power of 2. We can simplify it. Yeah, and move 6 out of integral. So t cube, here is 1, and here is t plus 1. So now we can simplify this expression with, so we can cancel denominator. How can we do it? We can expand, so we can factorize this expression. So actually, t in power of 6 minus 1 equals t cube plus 1. So this is the difference of squares. And what is interesting for now, we need to factorize these brackets. So let's do it. So here is sum of cubes. So t cube plus 1 equals t plus 1 multiplied by t square minus t plus 1. And now we can just cancel the denominator. And we will receive just a polynomial. It's going on. Mhm. Okay, so we have such expression. Now let we not waste our time to expand brackets, calculate powers, and so on. So we will receive such expression. And the following expression. So t in power of 8 minus t in power of 7 plus t in power of 6 minus t in power of 5 plus t in power of 4 minus t cube dt. So now let's integrate it. So 1 over 9 t in power of 9 minus 1 over 8 t in power of 8 plus 1 over 7 t in power of 7 minus 1 over 6 t in power of 6. Oh, okay. Yeah, I don't like integrating such huge expressions as well, but we have to do it to receive the final answer. So it's done. So it's almost done because we also need to either return to old variables or write down what does t equal. Okay, any questions about this exercise? About the lesson at all, maybe about the previous lessons?
No question.
Okay, so if no questions, let's finish. Actually, yeah, 11:04 now. So have a nice day, stay safe, goodbye. Feel free to text me if you have some questions.
Thank you. Goodbye.
Thank you.
Right,
Goodbye. Have a nice
thank
day
you
too.
for
Thank you for
right.
everything.
Thank you.